Um, I'm presuming that most of you were at the concert last night, and so, and that if you came to a thing like this, that you're interested in like technical details and geeky stuff, like how it works. So that's what I thought I would do. Let me just clear that. Is just talk about how things are put together and how the signal processing is done, how the control is done, and how we work together, Jean-François, how we work together to communicate to control the electronic aspects of the duo. So, and that said, so I prepared a sort of talk. So I prepared a sort of direction to go, but probably if I were to go into detail about things, we'd be here for the rest of the afternoon just talking about it. And so I'm going to jump around a little bit, and what I want also is if you have any particular thing that you're interested in, that you ask questions or that you raise points so that we can be more open in how I go through it, okay? So there's going to be some digital signal processing stuff, some control stuff, and some live performance issues. And so, I want to talk about the pieces actually in reverse order from the concert last night, because it's more of a historical order for me. The last piece that we performed, Head Transplant Experiment, was the first of the pieces that was composed. And it was more or less my first live performance piece. And so the sort of historical framework was that I was really interested in working with like sensors. So like pressure sensors, light sensors, magnetic field, gyroscopes, accelerometers, like a whole mass of stuff, and I amassed a big collection of them, and I developed all sorts of sound generating and processing devices, everything connected with sensors, and I had all kinds of really cool stuff going, and then I wanted to compose a piece, and then I started putting all these things together, and I arrived at a point where like nothing worked, because it was like, and just like weird stuff happened. It was like the computer the Max just like crashed like repeatedly, but not for the same reasons at the same time, with different kinds of errors. It was like there were like incredible slowdowns of communication between my controllers and Max, and so on and so forth. Like the schedule would stop doing anything, and so on. And basically, just I think the computer just couldn't handle the masses of information I was pumping into it. And at the same time, I realized I couldn't control all these things because I had like, gloves and things that were hanging up and things that I was under my feet and so on and so forth. It was just like too much to control musically. And so I just scaled down and got rid of all my sound generators except one, which used like 10% of the CPU. And I got rid of all the alternative controllers and controlled with me. And so I was in a stable situation. So this was this was like the musical reason was I needed something that I could perform and that would work always, or most of the time anyway. And musically that meant I had to change my direction because I've let's say, traditionally, or up to the moments when I became more involved with live performance, an electroacoustic composer working in a studio. I'm working with pretty high levels of complexity and polyphony. So a lot of different things going on at the same time independently. And as a performer, I had to change my orientation and think, now I'm writing, if I'm writing a piece for solo computer, it's like I'm writing a piece for flute. as one instrument. And so what I chose was to kind of sound material that could be really dense and rich inside. So it's one sound, but it's massively complex on in the inside of the sound. That was how I arrived at what became then head transplant experiment. The processing that's inside it was based on some various combinations of extreme digital distortions that I arrived at more or less empirically, fiddling around by doing relatively arbitrary things to signals. And I've been using them, these kind of processes, for a few electroacoustic pieces before, and so I arranged them, organized them, so I could have a good performance interface. And this is what I am. In a moment, this actually makes it easier now if I'd like. Oh, can I just mute the screen when I don't want it? Okay, it doesn't matter. It doesn't matter. I can just switch like this and put it in mirror so I can see. So it's easier. Okay. So then this is the patch as it is today. It's gone through various evolutions. And so basically what the signal chain is, and these are all P-patchers, each one of these blocks. So what the signal chain is there are two sound files which are being read here, and they pass through this processor, which is a square root and cosine, and then they pass through this, which is a bit shift, and then they pass through this, which is divide, and then they pass through a filter. Then there's some equalization, and then they go out to the output. So, just and there were other in the original patch. There were various other processes that were involved, and as I simplified the patch, because basically what I did is I built this instrument with like all these different possibilities, and I played with it and I played with it and I played with it until I gradually evolved into a structure of a piece, which then I actually noted. If you may have noticed last time, I was actually turning pages of a score, because what I have to do is written on a score. And so basically then I took out of this final performance patch the things that I don't need, or most of the things that I don't need. So for instance here, this module called square root and cosine, it has a whole bunch of different options, and the only one I use is this one. So this says cosine delta, and just as an example of the sort of arbitrary garbage that I can sometimes like doing with the signal. This is cosine, and this is delta. And you're just, can I presume that like everybody uses Max, and so, or if like I'm saying things that don't make any sense, can you ask me questions?
Maybe we could have a show of hands who's sort of familiar or reasonably familiar with Max.
I'm not familiar at all.
Okay.
Most people. Okay. I sort of think that was called the Max Symposium. I'm talking to people who use Max, and if not, hopefully understand globally the story. So here's the signal that's going through. It goes through a cosine, which outputs the cosine of whatever the value is, and the delta, which is the difference between adjacent samples. So if I take, which is, it's kind of like I said yesterday in the talk. It's like there's no plugin that does this. because nobody, no normal person would want to do this. So, if for instance I take a sine wave, if I just take a sine wave, so now we're listening to just this sine wave. The cosine, for some reason we don't see anything on the scope. And delta. So it's transformed the sound in some way that and it has one parameter in this process, which is the amplitude. So if I amplify what goes into the cosine, I've modified the sound in some way. So far, it's not very exciting. But it's a distortion. I have a pure sine wave on the input, and on the output I have a distorted sine wave, so it's rich in harmonics. So it's a kind of, it's a kind of distortion. So if I take a sound, file, which sounds like this. That's the cosine. And if I amplify it, I get some kind of nasty distortion. I take the delta of that. I get some other kind of nasty distortion. If I increase the amplitude, I get more distortion. Okay. Right? So, I find that kind of interesting. I'm using the wrong program. Next module is a bit shift. A bit shift takes, well, you know, that all information on a computer is just a bunch of zeros and ones, and so, for instance, every sample of audio is like, depending on the resolution, 16 or 32 or 64 zeros and ones. So if you take the sample that's 0001111 and you shift those, and so the first zero goes into where the second zero goes, and so on and so forth, you're basically mangling in a relatively extreme way the information. And it's an object that exists in Max to do like high-level serious signal processing. But you can just do stupid things with it, like take a sound and shift the bits. So if I take a sine wave, for instance, and here I have actually just reproduced my interface, which I think will become clear perhaps why I take my sine wave. Oh wait, because I changed programs. So if I take this, the sine wave, and I shift all the bits by 2, so we get silence. It just does weird shit.
Probably worth saying part of what, if you do this on integer numbers, it would just be like multiplying, where each bit shift is just times 2 or whatever. The key point here with the bit shift object in Max is that it's taking floating point representation and reading it as if it was an integer, which means that all of your amplitudes get totally messed up because the whole number has actually got 2 different parts and it's just treating them as a string of numbers. And that's kind of why it does these really unpredictable things with the audio.
Yeah.
Otherwise, if it was just integer based, it would just be like.
It would just be amplifying. Yeah. Yeah. In fact, doing weird things with the amplitudes. Here is my original, and these are the amplitude values, which are nicely between 0 and 1, actually. And this is after the bit shift.
Yeah, I mean, essentially any bit pattern can come out, so any floating point number could come out the other side.
Yeah. And it does. And sometimes it's just silence. That is, if all these numbers, okay, and so, well, afterwards, the values are clipped between -1 and +1. And as it happens, all these enormous numbers now seem to be below 0. And so the only output is -1, which is why we're hearing nothing. But we see a huge level. Okay. So that's because everything's clipped at 1. But if I change, and so yeah, lots of some settings produce silence, some settings just produce kind of white noise, and some settings produce other weird stuff. But if I put in a sound file instead of a sine wave, if I can find my sounds again, I'll put in that same one. It's good. Distortion. Sometimes a lot of the information gets through, and sometimes it's completely destroyed, and it's always really nastily distorted with lots of noise. And these huge numbers, therefore, mean you have to do something with them. And these are just various options for what to do with the fact that these numbers go way beyond our maximum of -1 to +1. And so, the first what we've been listening to, they're just clipped. Sorry. We're just listening to, the values are just clipped. I can also clip them and remove the DC. Depending on what we do with these numbers here, I'm just clipping them. And so there's just some clicks because I presume in these massive numbers, every now and then there's a negative number. Because all these positive numbers are clipped to 1. But there must be, from time to time, a negative, which is making occasional clicks. If I do a DC offset removal, it's going to try to take this enormous numbers and center them around 0, which means there's going to be a lot more zero crossings, and so we're going to have a lot more of the sound coming through. Folding.
Is that acting as a filter for the numbers then?
Yeah.
So you're sort of just excluding a load of numbers except for...
No. DC offset is a constant signal. So if you have like a normal, what a DC offset is your normal signal, it oscillates nicely around 0. But when you have a signal that has a DC offset, it oscillates nicely around 0.5, for instance. And so you have a DC offset removal filter, which basically is a high pass filter at 0 hertz. And so it removes 0 hertz, which that is, okay? And so it just takes that waveform that's oscillating around 0.5 and it subtracts 0.5, so now it's oscillating around 0. So what I have here is numbers that are in this realm that I couldn't even begin to pronounce in any language that are not 0.5, but they're up in the stratosphere somewhere, and it tries to bring them down to around 0. And so that means it's going to manage to get a lot more of them to cross the 0 point, which means we're going to start hearing more of the sound.
Cool. So it tries to sort of work out the spread and kind of shuffle it so that they're all passing around 0.
Yeah.
Cool.
Yeah.
Thanks.
Folding, well, and so what clipping does is any value that goes above, if you set a threshold, and you have an input that goes above the threshold, the output stops at the threshold. So if my input signal rises up and comes down, what's going to come out of the clip is just going to be cut off there, which is a nice form of distortion. What folding does is it makes the threshold act as a mirror. And so what goes up is mirrored, what goes above the threshold comes behind the threshold. So it's another form of distortion that's nasty. And what wrapping does is it treats what goes above the upper threshold, there's a lower threshold as well, comes back from the lower threshold. I don't know if that made any sense. If I have 2 thresholds here, if these 2 lines are my threshold, my input signal goes up like this. The wrap is going to cause it the part that would be up here would be down here. As if this space were too big. As soon as it goes above with the upper, it comes from below to lower, which makes an extremely nasty distortion. And with all of these things, that's between 0 and 1, and here we're at some astronomical numbers, which means all these operations are going to be applied many times. Which means it sounds different. And it grows globally, it's going to sound more distorted as you move up. But it's all equal. So, again, arbitrary processes that really destroy the sound, but have some character of their own. And what I do is just explore and develop and find things that are interesting and move in that direction. And see how I can control them and how I can modulate them and so on and so forth. Okay.
Could you open up the subfolder, the actual bit shifting folder? Just curious to see.
Yeah.
What we do.
Oops. That's it.
Yeah.
Bit
okay,
shift. Actually, that's almost it, because bit shifting goes by integer jumps. You can shift by 1 bit, 2 bits. You can't shift by 1.5 bits. And so basically, I just have 2 of them, and I crossfade between them, so I can have a continuous movement rather than just jumps.
Sorry, is bit shifting endogenous object? Or is it
Yeah, it's just a basic Max operator. even in the help patch, they have an SF plate going through. Third process that's implemented here is the division. And this process actually is right there. I have one signal and it's divided by another signal. Which, so if I take sine wave again, now I'm dividing that by 1. So I'm not doing anything to it. If I divide it by something greater than 1, I'm multiplying it by the inverse, so I'm just making it solve. And if I divide it by something less than 1, I'm multiplying it by the inverse, so I'm just amplifying it. And I start to get a distortion because I have a clip. And when I arrive at 0, I'm dividing by 0, which means I'm multiplying by infinity. And so it produces, except that they corrected it in recent versions of Max, and so now it just outputs 0. Before it outputted, it output plus and minus infinity. But anyway, it comes down to the same thing in practice, because 0 is just one value, but 0.000000001 is close enough. So if instead of a fixed value, if I take a sine wave, and this is the representation of that sine wave, basically I amplify extremely, going through a phase of distortion. Instead of that, I put a sound file, for instance, this one. That's the division of this sine wave and that sound file. If I take the sound file that we listened to before, this one, this one, this one, so this. It starts to get really interesting. I can also slow down the singer a lot because it's moving. The sound wave, I'm using this as a control signal, so it's changing really fast. But basically producing a lot of noise. I want it to produce noise, but it's nicer if it changes more slowly. So these are the kind of sound processing that's behind the piece, and that I just found by fiddling around and following things that interested me. after those sounds, there's yes.
Have you got all those sounds you just showed? Are they all in a line, or can you?
They're
Is the output of one fed into the input? Of
the
the
output
next?
of one is fed into the next. Yeah. In fact, in that order that I showed them, try to show them in that order. First, the one, then the next, and the next. It's just. And I've made patches where I have a matrix, so I can do them in different ways, and so on and so forth. But what I ended up with in this space was just a chain. And there's not always all of them activated because each of them has a bypass. And I also have a switch so the division can move in one way or the other way, and so on. And I have a lot of control over the sound file speed and level because that changes everything. So yeah, and after all those processes, again, there's filtering to improve the sound, basically, and clipping to keep it in a reasonable range. Okay, so controllers. So given that I'm working with this kind of process, then how do I control it? And I want to be controlling it in real time in the concert. It's going through like a whole series of generations and different configurations. Originally, I had, I don't know if you know it, the Behringer BCF 2000. Do you guys know what I'm talking about? You guys do. No, okay. It's a MIDI controller, the faders and knobs that has a fantastic advantage in that it's bidirectional communication, and so you can change something on the computer and it moves the faders. And it's also high resolution, so you don't just have 0 to 127 value. You have a much greater resolution. So I used that. Then I expanded into using the plus a BCR 2000, so two physical controllers, which are with let's say the same idea to simplify a little bit, and that I used for quite a while, but I kept running into a couple of problems, which is that the USB MIDI is just like, it's not very stable. It was like I'm performing a concert and like keep having to like, okay, unplug everything, plug everything back in between the pieces. Oh, let's just restart the computer. Or it works, but then if you go away and you come back, it doesn't work anymore. And I got really tired of that. And also I got really tired of having to, between pieces, like change the tape. The tape that says this knob corresponds with this parameter, and that knob corresponds with that parameter. And like the concerts were like there's like a whole series of tape like attached here, and like between the pieces I have to say, oh, that's head transplant, okay, that one, and it's and also two fill a suitcase. So ultimately, through 2 steps, I moved down to these, which are my favorite things. See, these guys are my students. That's why they're laughing because they've heard of this before. So now I can travel with my backpack, and the setup, yeah, and the setup is, once I establish the communication, is really solid and stable, and the way I can control the way I can set this up is completely corresponds to exactly what I want to control. And that is, if I need 5 faders, I make 5 faders, and if I need another one, I just add another one, and I make them a little smaller, which things like that you just can't do with physical faders. And I have feedback from the computer, so I know when I move a fader exactly what the value is. Before with the MIDI faders, I would have to move the faders, and on my score it tells me I have to go to 0.3. So I look at the score and say, oh, I have to go to 0.3, and this is the fader I have to move, and then I have to look at the computer and move it until I get to 0.3. But now I can see the 0.3 here. So it's much more user-friendly. just open that patch again. And after you press mute. I say it's really stable, it's a test. This isn't my patch. Oh. Yeah. What can I show you about these? Just whenever I touch, this is something that I developed a long time ago. Whenever I move a fader in the external world, it turns red on my patch, so I can see what I've changed. So what you can't see here is what I just said. Is that here I'm seeing exactly the same number. I just have all of my different parameters laid out how I want with different tabs. Actually, this is just and I have like really lots of nice control possibilities that you don't have with physical faders. Things like this. So this is, for instance, a parameter of the sound file levels that I vary like a lot in wild ways, and also the speed I vary in wild ways. You can sort of see this jumping back and forth between two values. Other parameters that I want to control much more delicately, they will only respond if I touch Q, because I don't want it ever to jump. It's something that I only need to move very gradually. And I'm able to, for instance, use the different bit shift stages, I'm able to control them directly here. Before I had to turn a knob and then look and see where I was. Or press a button once to go here and then twice to go there, and now I know I'm there. Bref. Yeah, I guess that's all I should bother to say. The program that I'm using is Lemon, which that's enough. It's Lemon. It's like just a really fantastic program. If you're interested in using this kind of a controller, you should just look at Lemon. It's very, very, very versatile. Here I'm only using a very tiny percentage of its power. It's really fantastic. And the other thing that's great is that I don't have to be anywhere near the computer, and I don't have any cables, and I can be anywhere. And that is, in this piece, I don't actually use it. I'm sitting in front of the computer, but in the next piece, or the previous piece in the concert in Rust, I was controlling it in the same way using this from the center of the room, because I was controlling the sound. And that liberation from being fixed to the computer is fantastic. Are we in time? I'm good. We're getting close to the end. Let me just say. Okay. If I just say a little bit about Rust, I think that gives sort of an idea of approaches. Oh, let me just open up another issue. The second piece that we played last night, which is called Rust. There's an issue of interaction between the two the two performers. So continuing with this idea of the question of control. Basically, just to give an understanding of how the piece works. Jean-François, who is playing his instrument, records onto the computer the first like 20 seconds or so that he plays. Then, for the rest of the piece, that information is read by the computer backwards, very, 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 very slowly. So last night we did the 19-minute version. Okay, so it takes 19 minutes for the computer to get from the end of what he played to the beginning of what he played. And the process is a granulation process used to apply this extreme time stretch. Okay. So that's the basic idea. And so that what happens in the piece is that, and while then he continues to play, the sound from the computer continues to evolve in this predetermined way. And the intervention that I have is, or that I have is that I can control the level of he's continuing to play, and his sound is passing through the computer and amplified and filtered. And all the sounds mix. And so there's a control basically of the balance, the levels of these sounds. The acoustic sound, the amplified filtered sound, and the computer sound, which is also filtered. That's the basic thing. And the issues that we had to deal with in making this a performable situation was that Jean-François needs to be on the stage and needs to be behind the speakers for questions of feedback. I need to be in the middle of in front of the speakers, because what I'm doing is very delicately controlling the balances of the sound. Jean-François has to send information to the computer, because he also controls the microphone levels, and he has to control when the recording starts and stops. And he needs some visual feedback, because he needs to know where we are in the piece, and he needs to see the levels and to have some information coming back for what's happening in the computer part, in addition to what he hears. And sometimes we need to be able to talk to each other. So we went through a series of ways of dealing with this. First, Jean-François had MIDI faders, which are connected by a long cable that came to my computer. But there was in the visual feedback, we had screen sharing. So it's possible to have one computer, like you can put a computer in file sharing, so that I can share the files with you. We can also do screen sharing, so you can see on your computer my screen. So we did that, but that worked for a while. But then I changed the computer or changed system or something, and it just didn't work anymore. And so how it then evolved was into using, to get rid of these two things which were not very stable, the iPad. So now Jean-François, he still uses a physical fader, because the iPad, it has no tactile interface. And if you're playing an instrument, you need to be able to play it without seeing it. So he needs a physical fader for that reason. So he has MIDI faders which are going into the iPad, and the iPad, his iPad, is translating that into open sound control and sending it by Wi-Fi to my computer, which processes it, which also sends it back to his computer. Oh, that's the one I wanted to show you. Not mine. Here. This might not be the latest version. So he moves his faders like this, he moves his faders, and you can that they will move here. That information goes to my computer, changes the parameters, and comes back. Yeah, and comes back, showing him when he moved fader 1 that it changed this parameter, and he can also see the sound file levels and so on. And so he has his visual feedback is all on the iPad, and his control is with MIDI faders. And that also again makes setup a lot simpler. It means he doesn't have this huge. He doesn't have the computer on stage. He just has a discrete iPad. He goes doop, and he's ready for the next piece. So I'm gonna stop there. Any questions?
Yeah, just more about the iPad. Do you ever find that your performance gets changed by the fact that you're using touch instead of like a
Yes.
physical control?
Yes.
In
Yeah.
what way?
Yeah, and my basic inclination is to say this is a different kind of control, and I want to use it to do different kinds of things to exploit its potential. Its potential is that I mean there are different objects that I can use. Like there's a multi-ball, and just grab 5 things and move them around. There's physical modeling, so you can take things and bounce them back and forth, which I use to some. Is to exploit this potential that I don't have with the physical fader. In practice, what you see here is mostly faders that will be just the same. And yeah, it does influence behavior. Like the thing that I was showing you, that like I move these faders around a lot. It's kind of harder to move them around when I can't see them. And so how I move them around is that, like what I was showing you where I was a few minutes ago with those large red faders. How I move them around in this animated way is different than how I move them around when I have faders under my fingers. So yeah, it does influence the music, and you have to adapt to it, adjust to it, use what's most adapted to what you want to do, and adapt what you want to do to what you're using.
Sort of following on from that, do you find there's a difference in the fact you can't actually get tactile feedback from it? So if you want to know what you're doing, you have to be looking at your hands.
Yes.
Do you feel that affects the kind of performance element of it? Because it's like when you see somebody playing a desk, for example, they aren't necessarily looking at their hands, they're actually getting into it, looking around, whereas if you've got to be focused on your hands, does that affect you as a performer, do you find?
Yeah.
Sort of been, but you don't find that to be overly negative?
I don't find it to be overly negative. I find it's a limitation, and I don't like it. I like to be able to feel what's happening with my fingers. But in mostly with physical faders, I mostly have to be looking at the computer for the instruments that I've built. You can build instruments where you don't need any visual feedback, but I haven't arrived at that stage yet. I always need to see what's happening, so I know what the values are, and so on and so forth. And so I find that in those cases, I probably have to look at the fader a little bit to find my way around it, and to read what I wrote on a little piece of tape. And then I have to look at the computer. So I have more looking to do than here, where I only have to look at one thing.
Right, yeah, so it's not really affected it.
So it has, but for most of what I'm doing, it's affected in a positive way, because I only have one place to look.
Cool.
Yes.
I wonder, for the second piece, I think it was when you were positioned by the mixer with your iPad.
Yes, yes.
If I remember correctly, you weren't really touching the faders on the mixer, you were doing everything. So I wondered what the particular logic was for spatialization and diffusion through the iPad or through the lemur.
No, I had the power to touch the faders on the mixer, but I never applied that power because we had a lot. We had enough time during our rehearsal and expert help of Pierre Alexandre, so that we had a blend, a mix levels in all the speakers that worked. And so the spatialization I was not touching at all. And so the spatialization that happened from all the interaction of all the sounds that were being pumped through all those speakers. Because there's a lot of phase information in there. Jean-François, when he plays it, there's two tubes and they're not tuned exactly the same. And what was coming out of the computer is not tuned exactly the same, but they're all close. And the granulation process also produces all kinds of weird phase stuff, spitting the sound out in different ways. And so the spatialization aspect comes from that. And what I was controlling was levels and filter. And that's almost entirely true. There's one thing that I panned back and forth a while. As getting near the end of the piece, there's a and now I have a panning control that I'm sending that sort of relatively randomly back. Yes.
Yeah, I'm curious about latency in this setup as opposed to your previous setups.
Negligible.
Okay.
I measured it and I forget what the values came out. It's a little slower than USB memory.
Okay.
But I'm doing really pretty fast things and it hasn't bothered me at all.
Yeah.
And I was concerned. I was concerned about that, but I haven't had any issues with it. Yes.
Do you use your own? Looks like you've made your own network, right?
Yes.
Do you always do that, or
Yes.
do you actually carry a modem around with you?
No, it's always use my own network. No, if I'm building a patch, I don't care.
Yeah.
But if I want to do anything with it, yes. Because if you use the university internet network, you can connect both of yours to it, and you have horrible and ridiculous latency. That is, you move a fader, and then a little while later it comes to the computer, and then now that they know where each other is, they are, then it'll work with a really bad latency. But once you make an ad hoc network, it works really nicely. But that also took me a long time to come up with all the exact configurations and the way to do it until it's solid and stable. And last night, I still haven't found all the variables, because last night, for instance, we went up on stage and I set up the network. I didn't do it ahead of time. I set up the network. I connected my two iPads to it. One of them worked, and the other one didn't. Jean-François didn't. So we did a full reboot, turned everything off, turned everything back on, and it works perfectly. In that situation, everything always works perfectly. It's like something happens with the passage of time that sometimes things lose their connection. Yes.
When you perform,
Yes.
do you pre-listen to what sound will come out of your computer with your headphones, or do you always enjoy what's coming out of your computer without pre-listening and enjoy whatever comes?
Can you repeat that?
Do you understand? Like, when you change your parameters,
Yes.
your sound changes.
Yes.
Do you actually listen to that with headphones before coming out through the speakers? Or do you actually work without headphones and enjoy what comes out
Yeah, it
as a
depends.
surprise?
It depends. Ideally, no. It depends. There are times if I'm in a more improvisational situation where I want to be able to audition the sound before pumping it into the mix. And in other situations, I don't need that. I was using headphones in the first piece last night, not in order to test this. in the first piece last night, sometimes I have used the headphones for that reason. Check it and make sure it's something that works, because I didn't show you that patch, but it's even worse than head transplant experiment. It's like it's got like all these parameters that are like arbitrary things, and it's like you change something. There's no real direct correlation between the parameter and the sound. So you don't really know what the hell's going to happen. And so for that one, it's like, okay, what is it? Okay, but the more I work with it, the less I need it. But what I was using this headphone for was to hear what I was doing in the mix.
To be sure.
So while I was playing, I was listening to just to my part to find out really what it was, because I couldn't hear it clearly enough in the mix, and also being behind the speakers.
Great. Well, thank you very much, Ben.
Thank you.